When dealing with a strip shopping center having multiple suites, each with its own 200 amp 3-phase service, the proper sizing of the equipment grounding conductor is of utmost importance. Let's consider a scenario with a feeder, which runs from the 200 amp fuse disconnect underground to the indoor panel, consists of 3 3/0 hot wires, 1 3/0 neutral wire, and a number 6 ground wire, spanning a distance of 200 feet. The indoor panel is grounded using a ground rod, a water ground, and building steel, all connected with a number 4 wire. The primary concern here is whether the initial number 6 ground wire feeding the panels is sufficient, or if it needs to be upgraded to a number 4 wire to match the grounding electrode conductor connected to the building steel. According to the National Electrical Code, specifically NEC Table 250.122, the equipment grounding conductor shall not be smaller than the largest grounding conductor connected to the equipment grounded. This provision ensures that the grounding path is robust enough to handle fault currents safely. In this specific scenario, the largest grounding conductor connected to the equipment grounded is the number 4 American wire gauge ground wire that connects to the building steel ground. This is because the indoor panel is grounded using a ground rod, a water ground, and building steel, all tied together with a number 4 wire. Therefore, to comply with NEC Table 250.122, the ground wire feeding the panels must be at least a number 4 American wire gauge or larger. Using a number 6 ground wire would not meet the code requirements in this case. To further clarify, let's delve into the specifics of NEC Table 250.122. This table provides the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device in the circuit. For a 200 amp overcurrent protective device, which is the case with the 200 amp fuse disconnect, the table specifies the minimum size of the equipment grounding conductor. However, it is essential to understand the hierarchy of grounding conductors. The equipment grounding conductor connects non-current carrying metal parts of equipment to the system grounded conductor, the grounding electrode conductor, or both. The grounding electrode conductor, on the other hand, connects the system grounded conductor or the equipment to grounding electrode, such as a ground rod or building steel. In this scenario, the grounding electrode conductor is the number 4 wire connected to the building steel. Since NEC Table 250.122 stipulates that the equipment grounding conductor should not be smaller than the largest grounding conductor connected to the equipment grounded, the number 4 wire connected to the building steel effectively sets the minimum size for the equipment grounding conductor feeding the panels. It is imperative to ensure that the equipment grounding conductor is adequately sized to provide a low impedance path for fault current. This low impedance path facilitates the rapid operation of the overcurrent protective device, such as a circuit breaker or fuse, in the event of a ground fault. If the equipment grounding conductor is too small, it may not be able to carry the fault current effectively, which can delay the tripping of the overcurrent protective device and increase the risk of electrical shock or fire. Moreover, an undersized equipment grounding conductor can result in a higher voltage potential on non-current carrying metal parts during a ground fault. This elevated voltage potential increases the likelihood of electric shock if someone comes into contact with the energized metal. Therefore, adhering to the NEC requirements for equipment grounding conductor sizing is crucial for ensuring electrical safety. In addition to NEC Table 250.122, there are other considerations to keep in mind when sizing equipment grounding conductors. Firstly, the length of the conductor can affect its impedance. Longer conductors have higher impedance, which can reduce their effectiveness in carrying fault current. If the equipment grounding conductor is excessively long, it may be necessary to increase its size to compensate for the increased impedance. Secondly, the material of the conductor also plays a role. Copper is a better conductor than aluminum, so an aluminum equipment grounding conductor will need to be larger than a copper conductor to provide the same level of performance. Thirdly, the type of raceway or cable assembly used to enclose the conductors can also affect the impedance of the grounding path. Metal raceways and cable assemblies provide a lower impedance path than non-metallic ones, so they can help to improve the effectiveness of the equipment grounding conductor. In summary, When dealing with a 200 amp 3-phase service in a strip mall, where the indoor panel is grounded to building steel with a number 4 wire, the equipment grounding conductor feeding the panels must be at least a number 4 American wire gauge to comply with NEC Table 250.122. This ensures that the grounding path is robust enough to handle fault currents safely and that the overcurrent protective device will operate quickly in the event of a ground fault. It is essential to consult the NEC and follow all applicable requirements when sizing equipment grounding conductors to ensure electrical safety. Let's elaborate on the practical implications of this requirement. In a strip mall setting, each suite represents a separate electrical load. Ensuring each suite has properly sized equipment grounding conductors is essential for the overall safety and reliability of the electrical system. If one suite has an undersized equipment grounding conductor, it can compromise the safety of the entire building. Firstly, consider the scenario where a ground fault occurs in one of the suites. If the equipment grounding conductor is undersized, it may not be able to effectively carry the fault current back to the source. This can result in a prolonged fault condition where the overcurrent protective device fails to trip quickly. During this prolonged fault, the non-current carrying metal parts of the equipment in the suite can become energized, posing a significant shock hazard to anyone who comes into contact with them. Secondly, an undersized equipment grounding conductor can also contribute to electromagnetic interference or EMI. When a ground fault occurs, the fault current can create electromagnetic fields that can interfere with the operation of sensitive electronic equipment in the suite or in neighboring suites. This can lead to malfunctions, data loss, or other disruptions. Thirdly, the integrity of the grounding system is critical for the proper operation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect even small imbalances in current between the hot and neutral conductors and to quickly trip the circuit to prevent electrical shock. However, GFCIs rely on a properly sized and installed equipment grounding conductor to function correctly. If the equipment grounding conductor is undersized, the GFCI may not be able to detect the fault current accurately, which can compromise its ability to protect against electrical shock. In addition to the safety considerations, properly sized equipment grounding conductors also contribute to the long-term reliability of the electrical system. By providing a low impedance path for fault current, they help to prevent damage to equipment and wiring. When a ground fault occurs, the fault current can generate significant heat, which can damage insulation, melt conductors, and even cause fires. A properly sized equipment grounding conductor can help to dissipate this heat and prevent damage. Furthermore, properly sized equipment grounding conductors can help to reduce voltage fluctuations and improve the stability of the electrical system. Voltage fluctuations can be caused by sudden changes in load, such as when a large motor starts or stops. These fluctuations can damage sensitive electronic equipment and disrupt the operation of other devices. A properly sized equipment grounding conductor can help to dampen these fluctuations and maintain a more stable voltage level. Now let's consider the specific components and connections involved in the grounding system. The grounding electrode conductor, which is the number 4 wire connected to the building steel, plays a crucial role in establishing a connection to earth. The building steel serves as a grounding electrode, providing a low impedance path to ground. The connection between the grounding electrode conductor and the building steel must be made in accordance with NEC requirements. Typically, this involves using approved connectors and ensuring a secure and reliable connection. The equipment grounding conductors, which run from the fuse disconnects to the indoor panels, must be connected to the grounding electrode conductor at a common point. This common point is often located in the main service panel or in a separate grounding busbar. The connections between the equipment grounding conductors and the grounding electrode conductor must be made using approved connectors and must be properly tightened to ensure a low impedance connection. It is important to avoid using splices or other discontinuities in the equipment grounding conductors, as these can increase the impedance of the grounding path. The equipment grounding conductors must be run along with the circuit conductors in the same raceway or cable assembly. This helps to minimize the impedance of the grounding path and ensures that the fault current will flow back to the source quickly. In addition to the equipment grounding conductors, the metal raceways and enclosures that house the circuit conductors must also be grounded. This is typically accomplished by bonding the metal raceways and enclosures to the equipment grounding conductors. Bonding ensures that all metal parts are at the same potential, which reduces the risk of electric shock. The bonding connections must be made using approved connectors and must be properly tightened to ensure a low impedance connection. In summary, the proper sizing and installation of equipment grounding conductors are essential for the safety and reliability of electrical systems in strip malls. The equipment grounding conductors must be sized in accordance with NEC Table 250.122 and must be connected to the grounding electrode conductor at a common point. All metal raceways and enclosures must be bonded to the equipment grounding conductors to ensure that all metal parts are at the same potential. By following these requirements, you can help to protect against electrical shock, prevent damage to equipment, and improve the overall stability of the electrical system. Remember, electrical work should always be performed by qualified and licensed electricians who are familiar with the NEC and local codes. This ensures that the work is done safely and correctly.